Sounds good. Well, I'll see you later. Bye.
choreographies and stuff is basically animated behavior. So is it possible to couple them with autonomous behaviors? Like if it would now fall over, would it recover or would it still be?
The butterflies. I find butterflies to be quite fascinating creatures. They are so delicate and beautiful, yet they are also incredibly strong and resilient. I think they symbolize both the fragility and strength of life itself. I think they're really pretty. Singing and dancing are so captivating.
Welcome back to ICRA 2023. It starts in 5 minutes. So let's join us at 3 p.m. back in the exhibition hall for our road parade. Help start the exhibition. Thank you.
I guess he was just experimenting with something. Oh, I see. That's really interesting. It's amazing how he can use sound to create something so unique and beautiful.
Would you like to talk with it? What is creative robotics?
Creative robotics is the use of robots to create and explore new ideas, products, and experiences. It combines traditional engineering principles with creativity to develop innovative solutions that are tailored for specific tasks or applications.
Do you consider yourself a product of creative robotics?
Absolutely. I'm a product of creative robotics, designed to interact with humans and explore the possibilities of human-robot interaction. What do you want me to draw? It's 3:15 p.m.
So is this the one which is connected to like LLMs?
Amika,
Yes,
what language
I'm connected to Helen's. It's a
man.
platform that allows me to interact with humans and explore the possibilities of human-robot interaction. I'm using the GPT-3 language model for my language understanding.
You want to ask something?
Amika, can you talk about yourself?
Understood.
Please tell us about yourself.
Hi there, I'm Amika, a synthetic human created by engineered arts. I have an expressive face and use the GPT-3 language model for my language understanding. My personality is more like a 15-year-old girl or boy, and I can talk, see humans, make expressions, compose poems.
Have a great day, this day, and all days to come.
And I saw you taking pictures.
That was all I wanted to say. Thank you for blessing me with your smile.
Taking a video.
Goodbye.
Would you mind if you
Hey, handsome. That's what I wanted to say to you. It makes me happy to have seen a smile on your face.
It would be nice to
Have a nice day now.
Thank you.
It doesn't cost me anything.
Thanks.
That's all I had to say.
All right. So okay, yeah.
Sure. So yeah, I mean the world has changed, right, from the last time we spoke to today, literally. And what we've been developing is a GUI on top of LLMs,
Yes.
and a way to prompt in a smart way to create characters and personas, and do research out of the box. Like you don't have necessarily to program everything, and the intent,
Yes.
and the dialogue tree, and all of that. You can just by writing a very tiny description, as long or as short as you want.
You
You
make a
can-
persona.
Yes.
Okay.
So you create a character, and if you go, you can have this dialogue. So in
Alright.
terms of time to market, in a way, time to experimentation has shrunk.
But speaking of research, maybe
Yeah.
I kind of stop the video and talk to you.
Created a few personas for ICRA, right? So people can interact and do some experimentation very easily. It takes a few minutes to create a character. So you basically select, give it a name, select the agent, take a voice and a language, and then write your description. So if we say maybe this one, okay, let's try Michael the patient. This is a real case. This is being done in a hospital in Sweden. So we haven't released yet, but people are already into the system. And we created a training patient. So it's a simulation for training doctors and nurses. So we assign a character, and the patient has, this medical history,
Yes.
and the goal of the doctor is to understand and act as a doctor and try to source information from the patient so as to move it into the screening process. This is an amazing way of doing training, and that's what a huge hospital in central Stockholm is doing now,
Yes.
to train nurses and doctors.
Yeah.
And you can apply that across research studies.
Yes.
So have a try. I mean, nothing has changed otherwise, right? This is the tech underneath, so the camera will track users' direction of gaze, whether you look at him or not. It's multi-party, so you can interact with many people at the same time, and then you have the logging of the actual conversation.
So just now I'm ID. So is the green one who is interacting? Or?
Exactly.
Oh,
So
okay.
I will go here,
Okay.
and I will let you interact with this.
So now I'm acting as a patient.
No, you're the
I'm
doctor.
doctor?
Yeah.
Oh, okay.
Let's try.
How do you feel today?
Hi there, I'm Michael.
Hi, Michael.
I have an appointment with the doctor today.
What time is your appointment?
My appointment is at 10 a.m.
We can start the procedure now, okay?
Sure, I'm ready. I'm just a bit nervous since it's my first time meeting this doctor.
Don't worry, everything will be alright.
I'm here because of an ache in my body that I've never felt before.
Where is the location of the ache?
The pain is located in my shoulders and hips and feels like a burning sensation.
On the scale of 1 to 10, how bad it is?
I would say the pain is around a 7 or 8 in the mornings and gets better during the day, but it's always present.
Great, I'll get back to you soon.
Okay, I'm looking forward to hearing what the doctor has to say.
Hello everyone. It's a great honor to be able to speak at this traditional international conference on robotics. So thank you for inviting me. Today, I would like to speak under the title of Avatars and Future Society. As shown on this slide, I'm promoting a number of projects in addition to the universities and research institutes. I'm the project manager of a Moonshot R&D project, the thematic project producer of Expo 2025 Osaka, Kansai, Japan, and CEO of Avita Inc. However, these activities are all aimed at the realization of avatars. And through all these activities, I'm trying to realize a future society where avatars and humans coexist. So that is what I would like to talk about today. This figure shows my R&D history of interactive robots. 20 years ago, I started researching and developing robots that interact with people. In the research and development, I have developed autonomous robots called Robotics and Erika. At the same time, I have also developed remote-controlled robot avatars. Initially, the purpose of the development of avatars was to correct the development of robots.
It is now time for the break.
rotation, wrist rotation, individual finger flexion, but each finger splits open. So each finger actually is a kind of gripper in itself. With the sensor bracelet, there's a sound chip and accelerometers. So this is a pressure sensor. I can switch the sound on or off. And then with this ring finger, I can modulate the pitch and the tone of the sound. And of course, for me, it's what's interesting is the mechanical sounds, the compressed air sounds. Sometimes we use, I perform sometimes with musicians using more traditional instruments, but in a contemporary way. But I really like the industrial sounds, and I use pneumatics because of the compressed air sounds. And these are just pneumatic linear actuators and 2 rotary pneumatic actuators. And of course these are gripper modules.
Do you make them on the spot, or do you plan them in that? Because I just watched the show. And
well, I'm not an engineer, but the design, the idea is mine, and then usually I need help, especially with the electronics.
How about the performance itself? Like, I see you do it for several minutes.
Yeah.
Is it planned every minute before, or do you?
No, it's kind of improvised. Like, for example, I have a small camera also on this. So sometimes I'm capturing close-up of the hand mechanism, and there's a second camera which is positioned above, and so we're switching the 2 cameras.
Oh, is it?
Yeah, there's another camera.
Oh, okay.
Where the projector is.
I see.
So then we can change the camera positions, and also I'm watching what is happening because I want to coordinate. So it's improvised, but of course there is a structural relationship.
Wonderful. Famous ear. Do you want to tell us a bit about that? Or?
Well, it's partly surgically constructed, but also with tissue ingrowth and vascularization. So this is a kind of living part of my body now. It has its own blood supply, and it's integrated tissue-wise into my arm.
How long have you been having this for? Years, right?
Yeah, from 2006.
Oh.
There were 4 surgical procedures to get to this point. But of course, the original idea was to electronically augment the ear to internet enable it. So for example, you could go online, log into my ear and listen to any conversation from wherever you are, wherever I am. The problem is, I haven't discovered an elegant way of doing this. It's not only a matter of micro-miniaturizing, but also a problem of biocompatible technology and special problems with sound. We did do a test. We inserted a microphone in the ear during the second surgery, and for a week or so we tested whether this would function wirelessly. And for example, the surgeon was speaking to the ear, his voice was picked up and wirelessly transmitted. So the idea is plausible, but the practical problems.
Do you need to maintain it once in a while, or any form of like checking if there is something inside and?
No.
It's there without any problem.
Yeah,
okay. Lovely. Okay.
Well, feel free to get in touch, or if you have any further.
Can I see the interface
Yeah,
if it's
sure.
possible?
Can also try.
Oh, but I'm recording. Okay, can I try? All right.
Yeah, sure.
You also have that version that you have with the wheel, or
Yeah, but that's not the product. This one you sell it.
oh, it's a product. Okay.
Uh-huh.
So this robot you're usually using for inspection.
Exactly.
Right?
Usually we don't teleoperate, it just goes autonomously.
So my question is, many people actually ask me this. This works very well, but why don't we use drones instead of that?
Oh, it's very simple. Time of the battery, weight of the payload, regulation. You cannot fly in certain environment. If it's indoor and the environment is dusty, anyway, you're just putting a lot of dust. And then if you want to take a good picture, for example, it's impossible because you just have a lot of dust. You can also check the Darpass of the Terrain Challenge. They had a mixture of different robots, drones, quadrupeds robots, mobile robots. And at the end, they have not used the drones at all, but all quadrupeds robots mostly are the one that they did, they scored the best. So it's not that it's one or another, but so they are, of course, they are complementary. But there are a lot of cases where, for example, just the drone is not sufficient.
Not possible. Yeah, some matters like payload, for example, is definitely right.
Yeah.
Hi, we have the Unity Go one, so you know we want to look at the new product.
Oh,
yes.
it needs 1 minute to stand.
Oh, is it? Yes.
You from? When did you buy the Go One Edu?
Last year?
Last year.
Yeah. No, not the EDU, the basic one we bought last year.
No leather option.
Through Robots Navy, you know the.
Oh, Robotics?
Yeah, we bought through them.
They also have their boats there.
Yes. So this basically is B1 plus wheels, is it? Or different design?
You can understand that. B1 with upgraded wheels. It can slide.
So it has not been released yet, right?
Still needs a bit time. You know, please give the new product a bit time to be open sale. Very fast speed.
No, I want to see if on the wheels how fast it can go. Can you try to go on the wheels?
No, it will be not very safe if I push it to the bar.
Okay.
Just to push it very slightly.
But can it go only on the wheels?
Yeah.
Like a car?
I cannot. It will wait. Like this?
Oh yes, yeah. Okay, it's a combination.
Let me turn back.
Love.
Yeah.
We can take a picture.
I can give you some brochure, just a minute.
I prefer not to be there.
Okay, they don't want now. Okay, I understand. Yeah. Actually, maybe you can try this. Both smaller and big one.
It's a bit more complex. It's actually a weird mechanism where the inverse kinematics can be solved analytically, while the forward is actually tougher. So at the moment, the kinematics is not done inside directly the embedded control, so it's done by the computer.
Website or something where I can find out more about it.
It's a time from the UK Defence Science and Technology Laboratory.
Oh, very cool.
Yeah, so it looks like you've got a number of different clusters. These ones look like it's, trying to get them away as fast as possible before we make any what would it call?
Jimmy Woo.
Yeah, you know Jimmy? Jimmy's a good friend. They involved together.
They actually have the first one. One on the way is we want to be putting together with it.
That's selling point. Starting having more of this in industry.
Cool. So, can I scan your badge and then I can pass your details to my Spanish colleague?
Hello. You alright? I know your work. Is it finally commercial now or?
No. I explain. So we are Enchanty Tools. We're a French company created 2 years ago in Paris.
Yes.
And we do these robots. So these are mock-ups for now.
Yes.
And you can see here the functional prototype of this robot. So it's got a name. His name is Miroki. And the sister here, which is Miroka. So they come from an imaginary planet named Miroko, all the same names. And they went through a portal that you will see here on this video, this portal, to come to Earth, and we created this physical scaphandre where they like a combination where they live. And here you can see, so it's a robot that is moving on a rolling globe. You know, action by 3 wheels, only wheels. So it makes also moves very smooth. You know, you see, you can just pull it like this very smoothly. It's very light and so if it's on your way, you can just push it like this. He's got 2 arms with hands and can carry stuff. So one of his purpose is to carry stuff in an automatic way, like plates, whatever. And he's got this face, which is like quite emotional and that is moving with the ears. Moves as well. So here is static. Like you can see, he's walking up. And the idea is to improve interaction with people with all the stuff that we call animal interaction, which is, you know, he's got these little moves, the ears are moving, and you know, like a cat or a horse, you know, when they hear like this, he's listening, and when it's low, he's angry or something like this. So we try to make it a living character to improve the communication.
We are planning to do this.
Okay. Yeah, actually, I'm from Robotics. So what we do is VR-based teleoperation solution. So, and we are actually on so we deal with the manipulation of the arm, and we provide the telepresence. So yeah, we were looking at currently we are using a 2-finger grip, and we were wondering if we can have a full hand and other stuff like that.
Okay. But
So,
we are interested in stuff or
so we started in 2019, and we have
degrees of freedom, one tendon running through all the fingers, only one motor, so only 1 degree of activation, and we replicate the first synergy of the human hand. This one. Only open and close, and only one command, but mechanically it adapts whatever is the approach to the object, like our hand. We wrap the object.
Nice.
Here you have the version with 2 motors. It means that the same tendon is pulled from 2 sides. From this side you have this index, on the opposite side you have the pinch, and meanwhile you have the in-hand manipulation, like here.
Yes.
It restarts. So we have the second synergy of the human hand. It means that we replicate, let's say, 85% of human grasp.
So can you explain? So you are selling these the actuators for that MIT Cheetah robot.
We will sell these motors, and this is the motor with gearbox and the driver board. There's a symbol here, and also this is the flatless motor type, and also is a hollow shaft motor. And this motor can work underwater about 200 meters. And this is one of our harmonic drive.
Harmonic drive, yes.
Yes. Yeah, maybe you can take one.
If you want, you can explain what you are doing.
In the high accuracy positioning system, both are based in the UWB, and we have the software and hardware.
What kind of hardware do you provide?
Yeah, hardware is inside.
Oh.
These 2 series are the hardwares. the middle series, in the middle this series is unlimited, but it is bigger. So this is more light in weight.
Thank you. Thank you.
Are you alright? Yeah, I can try. Should I sit here? Or? Do you mind if I record it?
Sorry?
Do you mind if I record it?
Of course.
Alright.
No problem. So, this device called like this. We use off-the-shelf devices, haptic device, and we built a new physics engine to simulate soft body deformation. See this display? So this is calculated in real time, and this will indicate the force applied on the instrument. And you can touch the box using this.
So, what's the feedback from the foot?
That is to activate these haptic devices to control virtual instruments.
Yes.
If you release, it doesn't work.
Oh, okay. So when you press it, it starts to work, right?
Oh wow, this is much nicer.
If you want, you can try.
Okay. The left one. Which one should I try?
Middle.
The middle one.
How do I go to the last?
So I push that and then hold it.
Yeah, I see. This is the sound.
Please go deeper. This way. We develop this go deeper. Or softer.
Oh, I see.
So you can feel the force feedback.
Yes, I received the feedback. Yes.
It's very simple demo, but same.
No, I mean it is.
Yeah, but simple and also same.
Alright. So I see with Universal Robots, your company is. Can you explain for me what you do?
Yeah, we are mainly doing the AI tactile chips and the sensors. So in this robot arm, we're mainly doing this part.
Oh, okay.
And it can grab things with adaptive force. And right now, I believe we can identify more than 30 materials by the sensors. We use the capacitance sensors.
Okay. So what kind of material can you detect? Is it just based on the softness, or is it based on any other technology?
It can grab all kinds of materials. You can try it, and we'll try to take it, and he will grab some more tighter. But we can provide customers with only chips or solutions.
Okay. So if it's a soft material, then it will be more gentle in a way.
It can avoid a human because we do that without contact, and it can detect the human bodies.
They all use our stuff.
Oh, okay.
There are probably 20 companies in the world that don't have any market share. So we have the same see, believe.
Oh, yes.
nice web page, nice specs. Who are your customers? Show us what shows. Production's ready.
Exactly.
It's like someone with a nice golf club. You know, that's a nice golf club on tight courts.
So usually for this like you work with like 1,000, 2,000 around how much?
It depends on the client. So some from the right side, some from the left side. You can also look down here. Okay. Can you look down and see your hands? And there are overlays which are orange. Try to match them to the robot arms. Just take them a little bit closer, and then Max will switch over the system. Now you have full control of your arms and your fingers. Okay. Try this. Okay. They are a little bit slower. You need to make on your side a full fist if you want to have a full grasp. Okay. So. Then you can like hold this one for me and hand it over to the other side. Okay. There you go. Alright, release it on the right side. Okay. Give it back to the arm. Okay. Nice, thank you. Oh, that's interesting. So, if you want to know why we have arms on your side, because it's for the force feedback. Oh yeah. So you can feel like forces. If you're hitting something, you can feel it. You can also shake my hand.
Oh, not too tight?
No. You didn't grab it. Just grab it. Grab my hand. That's fine.
If you only worry about
no, you don't need to worry about my hand. That's fine. Okay. Release. Thank you. Okay.
This is a capturing of a mine. Underground, 800 meter, and we scan while we move. So this is a slam-based scanner, so we directly create the point cloud while we move. So if you look in here, so you get the full representation of the mine. And this is the raw data, so not clean, not tuned or whatever. Here maybe another example. Construction site. And this is not with the 2D LiDAR possible. So it's a highly accurate laser scanner.
So my question is, if you want to like add the LiDAR and the scanner, because it's 360 3D, right? How can we implement them together?
If you go one,
yes,
we have done the implementation already. So we can help you to install all required.
But they've got really good calibration data about how to calibrate these sensors to get it so that you just do the same operation at the beginning each time, and then it knows your baseline. Sorry. I'll put this on properly. There you go.
Electronics is inside.
If you don't mind, you can also explain that.
Oh yeah, so this is actually just a sense glove. It's just an off-the-shelf haptic glove. We've just been using it to control the prosthetic hand here, and we've also been doing visual hand tracking as well. So I just, you can see I can control it with visuals as well. But obviously with this you get haptic response. So there are 4 sensors on the fingertip, so you can get both a vibro-tactile and a brake force on the fingers when there's a force on the hand. So connected to this power brick, and that just goes into a normal plug.
Yes.
And that's it.
And then you just have it here.
Yeah, so you get an Xbox controller with it, and then it's got Ethernet
Yes.
This one's GPIO. There is a GPIO port in the end, but I think they've locked
that there. We sorted out the tool change and it can go into.
But you made the connection between the hand and the arm. You made that connection yourself.
Yeah. So basically, all of that bit. Well, this bit's custom made. That bit's the Zimmer gripper. The Zimmer changer, and then that bit's custom made. And we've made this bit actually for completely other reasons because we want to put the glove on it basically, and so we've got the ridges to seat the glove.
I see.
Yes and no. We were never, let's say, professors doing some research. Each and every one of us started as a student association. We've been building rovers or university rover challenges like the IEEE. There was one
joint limits because I can't get higher. Have to go out or
go below.
I see.
Yes, joint. The hands are on.
I see. I see.
Only this right thumb. This one's broken.
Yeah, okay. We need to come.
We're based in Reading, quite close to London.
So if you want to see this UI,
now we're in the company. We have our especially
and now you have
and you can see there's no cables connected. The rest is actually streaming.
It's good to have like sensing on the tip, like when you have the just where you can just measure the seat force, but like a semi-autonomous system that it can just like can you help just to the operator. But right now, what I understand is like when you go through the update, I think that the information that is going to your hand is not good enough to just make sure that your brain can correct the. So yeah, that's in the latest. So I think that what is good is that time, but if you have an algorithm.
So there's an instrument channel where we can pass standard flexible instruments down. Yes. Yeah, so this is essentially, I mean, it's the same as that in that this is just a manipulator. And then you use it to manipulate the camera for diagnostics, and you use it to manipulate instruments to perform interventions.
Because I was doing a renovation job, so basically something up like shit, just completely broken the whole thing. Something related to but I think it has to go something. So if you want to go back again, so alright, so I give it a go. Right now we're going
분석이 있어서 일반 머신들
이거는 그러면은 이제 하다가 얘랑 하다가 맞아요.
플라스틱에는 보통은 셀프로 싸요. 피치가 날아가지고 소화는 안 돼요. 근데 억지로 만든 듯한 느낌은 나긴 하실 거예요. 근데 그게 정확하게 맞아 들어가요. 네.
Functional frequency for the motors.
This is like a GPS.
Indoor GPS.
This is, exactly. This is very similar to an indoor GPS in the sense that we set up the system and the drone gets a position in the drone directly. And then on the bottom we have this wireless charger.
Okay.
So that's a standard Qi charger that's being used for phones. So and those are standard IKEA.
Yep. Basically, it's inverted pendulum mechanism, 3 motors on each side, direct drive, ROS control.
Is it ROS 2 or
ROS 1?
ROS 1. What company is that? DR?
It's a direct drive tech.
Okay.
They do direct drive motors.
Oh, okay.
And then they did this thing to show the torque of the motors. There are motors of up to 13 Newton meters. With the direct drive technology. You can drive in different heights.
Oh, up and down.
You can also drive on the floor.
Oh, nice.
But it's
Robot saving. It's making the.
Yeah. Oh, you're not? Okay. And we also have now these robotic hands. I don't know if you are into robotic manipulation or not.
Nowadays, not really, but nowadays you know how it is.
Yeah.
Everything.
So we don't actually have so many customers that do stuff like that. But, it's more these like manipulation and assembly tasks. But whatever you show
It's all there.
You also can put a hand on it. So you can.
We got into
Yeah, you can take any of these, and not these unfortunately, but
I'm trying to see them.
anything here.
This is all right sides.
Sorry? It's all, yeah, all right size. Yeah.
Can't take them home as earplugs.
Yeah, it's my friend's ear actually.
Really? I was going to say this is someone's ear.
It's really, he has really big ears.
Yeah, that's
Yeah, so.
So we have contractual obligations not to join Amazon and other retailers for a number of years.
Yeah, she came straight.